Hello, welcome to the OMICRON Customer Care Center in Klaus, Austria. My name is Alexander Herrera, and I am an application engineer with focus on rotating machines. Let me show you how to perform partial discharge measurements on our stator winding that we have prepared here in our training center. Partial discharge testing is one of the most sensitive methods to detect insulation defects in rotating machines, such as voids, delamination, slot discharges, or end winding problems. This stator winding is a three-phase stator with the start point accessible, so that's why we are going to measure phase by phase. While we are testing one phase, the other two phases will remain grounded. Safety is always very important before touching any cable or any connection. Make sure that it is completely grounded. In this setup, the CPC 100 with TD15 and CR600 supplies the AC test voltage, while the MPD 800 captures the partial discharge activity. The analysis includes discharge magnitude, repetition rate, and phase result patterns. We have already measured the first phase. Now we can proceed to test the second phase. We have finished already all the measurements, and now we can proceed to the next measurement. With similar setup, you can continue with dissipation factor, capacitance, and withstand voltage measurements, saving a significant amount of time. I want to show you how to interpret the data concerning to the partial discharge measurements performed on our rotating machine. By means of the MPD suite software, we have several tools available to interpret the data. First, we have the PRPD diagram available here, where we can see the measurements or where we can see the PD activity. Over here, we have the applied voltage and the charge that has been measured. I'll replay the data set. While the data set is replayed, we see what is the charge that is measured. We also see the test voltage here. We also can click on pause, and then we can take a close look to the PRPD in order to determine which type of PRPD pattern is developing. We can continue with the result, with the measurement, and the test voltage is also visible here. It is possible to compare the results or the measurements with previous measurements. In this case, we see that the PD activity, the magnitude of the PD activity is really increasing dramatically, so we can make a change of the scaling here. It's very important to know to use a linear scaling for when we are analyzing PD activity on rotating machines. So PD activity is extremely high. The test voltage now is 12 kV, and we are measuring close above 400 nanocoulombs. This is obviously not normal. However, this measurement might indicate problems in the end winding area of the stator winding. Thank you for watching our video.